Good morning, students. Hope you all are well. Today we will start our topic interrupts. What is an interrupt? Interrupt is an event that causes a temporary suspension of a program while serviced by another program. Means while we are executing any instruction or any program, there is an external request. So we have to stop our program at that time and first execute that external request, and after completing the execution of that request we have to move to our program where we stop. Okay, because processor cannot execute more than one instructions at the same time, so it will temporarily suspend the execution of that program which we are executing, and firstly execute that interrupt and then return to the main program. These are the steps for the execution of the interrupt. While we are executing main program, before interrupt request, it's starting initially when we are executing our main program. Then when we get interrupt request, so we have to save our data in register or stack and then reset its hardware, and then we have to call ISR. ISR is interrupt service routine, which is used for the execution of interrupt, that is for interrupt handling. After execution of that interrupt, we will restore our data which we store in that register. We will restore it and then return to the main program and then execute that program. These are the basic steps for the interrupt execution. Okay, when we are executing main program, then when we got interrupt request, so we have to stop our execution of the main program. So we store that address in the register and start executing that interrupt with the help of interrupt service routine. Then after executing this interrupt with the help of this routine, then we have to continue to execute our program, main program. So we have to restore that address from that register and return to the main program and then execute it. Okay. Now, basically interrupts are of different types: maskable interrupt, non-maskable interrupt, vectored and non-vectored interrupt. Maskable interrupt means which can be ignored, and non-maskable interrupts which cannot be ignored. Means if the request from maskable interrupt, it can be ignored, but if there is a request from non-maskable interrupts, we can't ignore it. We have to execute it. Vectored and non-vectored. Vectored means there is an interrupt vector table in which the addresses of the interrupts are fixed, are predefined. So in case of vectored interrupt, addresses of ISS is fixed for that particular interrupt. And in case of non-vectored interrupt, addresses of interrupts are not fixed. We have to ask for the address of that particular interrupt on receiving that interrupt. Okay, in case of vectored, addresses are fixed, and non-vectored addresses are not fixed. Okay. So next is interrupts in 8051 microcontroller. There are basically 5 interrupts in 8051 microcontrollers. 2 external interrupts, 2 timer interrupts, and 1 serial communication interrupt, serial port interrupt. 2 external interrupts are external hardware interrupt 0, INT 0, external hardware interrupt 1, INT 1. This 0 and 1 means there are, we know that in case of 8051 microcontrollers, there are two timers or counters, T0 and T1, timer 0 and timer 1. So that's why there are two interrupts for that, 0 and 1. Similarly, two timer interrupts, timer 0 interrupt TF0, timer 1 interrupt TF1. These are basically timer overflow interrupts. Timer overflow 0 and timer overflow 1. And the last one is serial com interrupt. Basically it have two interrupts, RI and TI. RI is receive interrupt and TI is transmit interrupt. So these are the basic interrupts. Now the question is, what are these interrupts? Like these timer interrupts TF0, TF1, these are timer or counter overflow. When these are set to 1, that means timer flag 0 or timer overflow flag set to 1. Means when timer overflows, these bits have to be set to 1. Similarly for external interrupts and for serial com interrupts. And the most important interrupt is reset, which is the highest priority interrupt, which we can't ignore. Upon reset, 8051 microcontroller starts executing its codes, its program from 000 address. And these interrupts, these 5 interrupts can be enabled or disabled with the help of IE register, that is interrupt enable register. This is a part of SFR. SFR is special function register in 8051. So IE is 8-bit register in SFR. This is bit or byte addressable. Bit means IE is 8-bit, so IE0 to IE7. And byte is that its addresses start from A8H. A8H to AFH is its bit addressable area. So this is interrupt enable. 8-bit register D0 to D7. These are the bits which is used here. So D0 bit is EX0, that is enable external interrupt 0. 0 for timer 0, timer 1. So 0 means timer 0. EX is external. ET is timer. So EX is for enable external interrupt. So EX0 and EX1 enable external interrupt 0 and 1. ET0 and ET1 for enable timer 0 and timer 1. ES is enable serial port interrupt, that is RI and TI. And the main is EA. EA is enable all bits. Enable all these bits. If it is 1, EA is 1, that means all bits are enabled, and if it is 0, then all are disabled. And similarly for these bits, if EX0 is 1, that means it is used to enable external interrupt 0, and if this bit is 0, it is used to disable external interrupt 0. So it's same for all. 1 means to enable that particular bit, and if it is 0, that is disable that bit. Now these interrupts, I have already told vectored interrupts. Vectored interrupts are those which have fixed addresses. So interrupt vector table is this. These are our interrupts and these are their vectored addresses which are fixed. So at starting reset, which is the highest priority interrupt, their vector address is 0000, As I have told you earlier that upon reset, 8051 microcontroller starts executing from 0000 address. So its vector address is 0000. H for hexa. And external interrupt 0 is 0003H. And address for timer 0000BH. Similar for external interrupt 1 0013. External interrupt 0 is 0003 and external interrupt 1 is 0013. Timer 1 interrupt is 001B. Timer 0 is 000B. Timer 1 is 001B. And for serial COM interrupt is 0023H. H stands for hexa. So these are the interrupts and these are their addresses. So it is interrupt vector table. These interrupts have priority. Means if we are getting request from one interrupt, then we can execute that interrupt. But if we get request from 2 or more interrupts at the same time, then how we will decide that which interrupt has to be executed first? So these depend upon their priority of interrupts. That is interrupt priority register. It is also an 8-bit register in SFR, special function register. It is also bit or byte addressable. Byte is B8H. Bit is IP0 to IP7. That is interrupt priority register. 8-bit register, so 0 to 7. And according to memory address is B8 to BFH. This is used to set the priority level for the interrupts. These are the priority levels. Highest priority is of INT 0, that is external interrupt 0, then timer interrupt 0, then external interrupt 1, then timer interrupt 1, and then serial port interrupt. This is the priority for the execution of interrupts, highest to lowest. Highest is INT 0, then timer 0, then INT 1, then timer 1, and then serial port. To give a higher priority to interrupt, corresponding bit in this IP register is made to be high. That means set. This is the IP, interrupt priority register. It is of 8 bits, D0 to D7. 3 bits are for future use, and these 5 bits are used for PX0. 0 represents timer 0. 1 represents timer 1. So PX0 is for priority bit for external interrupt 0. PT0 is for priority bit for timer 0. PX1 is priority bit for external interrupt 1. PT1 is priority bit for timer 1 interrupt. And PS is priority bit for serial port interrupt. These are the 5 interrupts, and according to these 5 interrupts, we have these 5 bits to set their priority. Okay, so this is our interrupts for 8051 microcontrollers.